Welcome to AMI Day 7. Today we're going to do trig ratios of coterminal angles. To be able to do this, the first thing you have to know is the unit circle. You have to know it frontwards, backwards, sideways, every which way but Sunday. We call the unit circle centered at the origin with radius 1. You need to be able to completely fill in all of these that I'm going to fill in here. Centered at the origin, radius 1. You need to be able to completely fill in all of these places marked on a circle with their degree measure. Whatever works for you to figure this out. A lot of things on here are very similar, so if you try to memorize it all, just straight memory, not very many people are going to be able to do that accurately. Remember the circle's 360 degrees? If we go 30 degrees at a time, we get all the way around the circle, or if we go 45 degrees at a time, we go all the way around the circle. We can come up with those by just adding to 0. So 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, so on and so forth. You also have to be able to label these with their radian measure. And finally, you have to be able to label the coordinates. We already labeled on the axes. Square root of 3 over 2, 1/2. Square root of 2 over 2. Square root of 2 over 2. 1/2. Square root of 3 over 2. The reason this is all important is because the sine of any angle is its y-coordinate on a unit circle, and the cosine of any angle is its x-coordinate on a unit circle. You can see all these square roots of 2, square roots of 3, square roots of 2 over 2, all this, these are very similar and easy to confuse if you don't know this circle. You have to know and understand the circle. As I told you while we were in class, everything I teach you in trig is going to be based off this circle. And if we ever get back to class and have a regular test, I will make this blank circle available to you, and it will be worth 25 points on every test we get after that. And that's completely filled in the unit circle. Now the reason we need that, we're mainly going to talk about coterminal angles, angles that are coterminal with these angles that we know on the unit circle. Anytime you have an angle with some number over 3, some number times pi over 3, anytime you have some number times pi, anytime you have some number times pi over 2, some number times pi over 4, or some number times pi over 6. Anytime, those angles will be coterminal with an angle on a unit circle. And anytime coterminal angles have the same values for every trig ratio. And we can use this to just count. If I want to find, these are all angles between 0 and 2 pi, or between 0 and 360 degrees. So if I wanted to find, say, the cosine of 17 pi over 4. Oops. That's going to be coterminal with the angle on the unit circle. I can count by pi's over 4. If we look at this, pi's over 4, this would be 1 pi over 4. Every 45 degrees is pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4, 14 pi over 4, 15 pi over 4, 16 pi over 4, 17 pi over 4 is coterminal with pi over 4, so the cosine is the square root of 2 over 2. If we want to find the sine of 12 pi, no, it's not 12, let's do 15 pi, 15 pi over 6. Every 30 degrees is a pi over 6. So we can count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, 13 pi over 6, 14 pi over 6, 15 pi over 6. 15 pi over 6. 15 pi over 6 is coterminal with pi over 2, so the sine of 15 pi over 6 is 1, the y coordinate. Let's say we want to do the tangent of 14 pi over 3. So we're going to count again. This time every 60 degrees is a pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3, 13 pi over 3, and 14 pi over 3. So the tangent is always going to be the sine divided by the cosine. So that's going to be the square root of 3 over 2 divided by negative 1/2. When we invert and multiply, 2's cancel, we end up with negative square root of 3. Let's do some more of those. This time let's do some negative ones. Let's do negative, let's do cosine of negative 19 pi. Now, anytime you have just a number times pi, this gets pretty easy, because every odd multiple of pi is going to end at pi, and every even multiple of pi is going to end at 2 pi. I'll show you this. First off, we go negative. We're counting in the backwards direction, clockwise direction. So we're going to go negative 1 pi, negative 2 pi, negative 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 10 pi, 11 pi, 12 pi, 13 pi, 14 pi, 15 pi, 16 pi, 17 pi, 18 pi, and 19 pi. Negative 19 pi is going to end up being coterminal with cosine pi, and that is, of course, negative 1. Let's do sine of negative 11 pi over 3. Again, we're counting backwards, or clockwise this time, going by 60-degree increments because pi over 3 is 60 degrees. So 1 pi over negative 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, negative 11 pi over 3 is equal to sine negative 11 pi over 3 is equal to sine of pi over 3, because those two are coterminal, and sine pi over 3 is the square root of 3 over 2. Let's do tangent of negative let's do negative 11 pi over 4. Remember, we're counting by 45 degrees because pi is over 4, 45 degrees. So we're going to go backwards. 11 pi is over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4. Negative 11 pi over 4 is going to be coterminal. 11 pi over 4 is negative 11 pi over 4 is coterminal with 5 pi over 4. So we're going to do the tangent of 5 pi over 4. And that's negative square root of 2 over 2 divided by negative square root of 2 over 2. That's just negative 1. If we were going to do cosine, haven't done any pi's over 6s, have we? Let's do negative 13 pi over 6. So again, we count by 30 degrees because that's pi over 6, so we're going backwards, clockwise. Negative 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, 13 pi over 6. So negative 13 pi over 6 is coterminal with 11 pi over 6, and the cosine of 11 pi over 6 is square root of 3 over 2. Let's do one more. Let's do the pi's over 2 this time. So let's do sine of 13 pi, negative 13 pi over 2. So we got negative 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2, 12 pi over 2, negative 13 pi over 2. Negative 13 pi over 2 is coterminal with 3 pi over 2. So the sine 3 pi over 2, sine negative 13 pi over 2 is negative 1. And that's how we do trig ratios of coterminal angles.